Last class, we talked about finding the least squares regression line. We also talked about correlation. What was that phrase that we said? Correlation 3 times? Causation. No. Yes. No, correlation does not imply causation. Cause is a bad word, right? So,
I said correlates.
When we are looking more at the least squares regression line, or your line of best fit, we say x is our independent variable, y is our dependent. We use values of x to predict y. So this is the formula. Y hat equals a plus bx. Y hat means predicted y. Be sure to put the hat on it. B is your slope. A is your y-intercept. In some situations, your y-intercept does not make sense. So I want everyone to go to page 99. Page 99. I have printed out all of your scripts that you need to memorize for this chapter. So page 99, you do need to memorize. So if I asked you to interpret the slope, then in context you would say as you're increasing by 1 unit of x, your y will increase or decrease by that slope. For the y-intercept, it's when your x value is equal to 0. You have to discern whether your y-intercept makes sense or not. So does it make sense in context for my x value to be 0? An example of where it doesn't make sense, if I were measuring height versus weight, is anyone on this earth 0 inches tall? No, it's not possible. So if I had, if my formula were y hat equals 13 plus 2x, and my variables were height and weight, then this 13 does not make any sense. It wouldn't be when you're 0 inches tall, you weigh 13 pounds. That does not make sense. So in that case, you would say the y-intercept does not make sense in this context because it is impossible to be 0 inches tall. So for your y-intercept, you either interpret or you say it doesn't make sense because, and then you list the reason. So for the y-intercept, you have to discern. For the slope, it's always increasing x by 1 unit becomes an increase or decrease by your slope. These are the formulas that you do not need, but they are on the formula chart. Remember when we solved it algebraically, those 3 formulas on the formula chart.
You said we don't need those?
They're on the formula chart. That's only whenever you are not given the original data, but you're given your x and y bar, so your means of your x and y, and then standard deviations. Your least squares regression line is the line that minimizes all of your deviations from the line. So basically, the line that is drawn is minimizing all of the distances from your original data points on the scatter plot. So here we have 3 data points. If I were to just kind of guess what I would think would be the line of best fit, or the one that goes in between all 3 of these, I would probably draw something right here. Now if I found the vertical distance from all of these, the deviations, here are my numbers. Do these add up to 0? No, they do not. So the actual line means that your deviations add up to 0. Now it doesn't really look like it's in between the 2. It's actually closer to the 2 data points. Why do you think that is? Because there's 2, so there's double, so they're pulling them down. So your line's going to be closer to where you have the most data points. Will it always be 0? Yes, your deviations will always be 0. We're now going to start calling them not deviations, but residuals.
Okay.
Oh, that's not the next slide. I thought it was. It'll come in a second. So here we have, this is always a really weird example, but we're talking about, they're studying pomegranate antioxidant properties and seeing if those are helpful with the treatment of cancer. That was an actual study that was done.
No pomegranate.
So what they did, and I don't know if you're okay with this, but basically they injected 3 groups of mice. One of the groups got plain water. One group was, they were given cancer. I don't know if I personally agree with that, but that's what they did. One group was given 0.1% of the pomegranate supplement, and then the other group was given 0.2% of the pomegranate supplement.
Imagine going to work and giving mice cancer.
What did you do today, honey? I gave mice cancer.
So then what they did is they measured the number of days. So your X is the number of days after injecting the pomegranate. And then...
The whole pomegranate?
And then, yes, the entire pomegranate into...
That's when the mice died, not
the mice. And then Y represents the average tumor volume. So
in other words, the pomegranates gave the mice cancer.
That's what I'm thinking, because it's supposed to work.
Correlation.
That's kind of what I'm thinking, is that it caused it. So here is my scatter plot. I'm not going to make you put that in. And here is the LSRL. Now, we all are aware of how to do so. You put it in L1, L2, Stat Calc 8, right? Now, I want to interpret. So the reason why I didn't make you guys do this is because I know that you're pros at it and you're masters at it. So we're not going to spend our time doing that. But I do want us to interpret the slope, the correlation coefficient, and the y-intercept based on these data. So first off, let's interpret the slope, which is the 37.25. If I were to interpret that, I'm going to erase this. 37.25 is my slope. So if you're looking at your interpretation, you can look on page 99 or the slide next to it. Then how could I write a nice sentence explaining that? There's nothing nice about this example, but how could I write a sentence?
So we also put mice with cancer on our t-shirts.
Yes. For each, and I want you to stay as closely to this script as you can because you can't go wrong with it, okay?
For each
Increase in, what is 1 unit of X in context? For 1 day. So, for each increase in 1 day, there is an approximate increase in my Y, so in tumor volume, average tumor volume, by 37.25, and then is it millimeters cubed? I think that's it. So the things that you're inserting is your context of X. So this is my 1 unit of X, 1 day. This will change depending on if you have a positive or negative slope, increase or decrease. And then my Y. So other than that, it stays pretty constant with what you say, consistent.
Are we allowed to use acronyms? Or
Abbreviations, if they're common, then yes.
so
Like between, approx is fine, average, AVG, that's fine. Okay, y-intercept, let's talk about that one, because it is negative 269.75. Because if I were to interpret this at 0 days, because that's when X is 0 days, the tumor volume is negative. Does that make sense?
Wait, I understand the idea. So it's saying after however many days, when you multiply 37.25 times x, after that many days, once you reach 269, then cancer starts appearing, right? Or tumors.
In this particular data set, yes, but overall it doesn't make sense. Like, if you were to interpret it in this context, it doesn't make sense.
You can't have a negative.
So the y-intercept does not make sense in this example because volume cannot be negative. So that's what I mean by discerning whether it makes sense or not. Now, if you had a positive answer, could this make sense technically? Yes. Does anyone have any idea as to why we have a negative data set? If you look at my x values, what are they in between? Like, what's my range of x values? My smallest x value is what? 11, and then my biggest is 27. So my line of best fit is only going to accurately predict everything between 11 and 27. Anything outside of those, it's not going to be accurate. So anything outside of that range of x values is going to be what we call extrapolating the data, and we'll talk about that more in a minute. But it's a great line of best fit in between those data sets, but anything outside of those regions, not going to be so good. So that's why it keeps going downward at that rate, or I guess up, but it starts at a negative value in order to reach where we are from 11 to 27. Okay, the last thing is my correlation. So I want to interpret my R. This is where we use the acronym LSD. So there is a strong, positive, linear correlation, relationship, association between number of days after injection, I'm running out of room, and tumor volume in mice. I ran out of room, sorry. I wasn't there.
Hallie Thorne was like 4.5 feet tall when she was 4 years old.
That's on the video. I want you to know that.
Oh, hi Hallie. You were really tall when you were there.
She never takes this class. So, do not extrapolate. Don't predict for values outside of your X value range. And if you ever...
Honey is not much.
Like, really came out of the womb with dad's shoes on.
The air wheels are harder.
Okay, next thing. What if they switch it around and they want you to predict the number of days? This is important. They want you to predict the number of days and they give you a tumor volume. No, you don't. You don't do it because you would kill a puppy. You never, ever, ever, never plug in for something with a hat on. I'm going to write that out. Never plug into a hat, okay? Never plug into a hat. Never plug into a hat. Now, what you do is you are going to switch the formula around and you're going to create an equation that is x hat equals a plus b y. It's really simple. All you do is you switch the two lists. So I'm going to do stat calc 8 and I'm going to switch this, my first to be list 2, my second to be list 1.
That changes it? I thought it didn't change it though.
It changes your least squares regression line. It doesn't change your correlation. So let's try that. Now, if you haven't y'all haven't typed in the data at all. So we're going to put this in list 1 and we're going to put our x's in list 2.
Switch it around real quick.
Switcheroo.
So excited to switch this up.
What do you get for your x hat equation? X hat equals 7.277 plus 0.027 y.
X hat.
Now, is 500 okay to plug into? Does it fit within my range of y values? Yes, there's no extrapolating going on, right?
No extrapolation.
So plug in 500 now for y, and you get x hat equals something.
20.777.
20.777. Is that what you get? So let me say this again because this is a very common mistake that I see people make. If they want you to plug in for y, you cannot do it because it has a hat on it. So the reason why it has a hat is because it's predicted. You can't plug in something that you're supposedly supposed to be predicting. So you have to switch the two variables, then create a completely new LSRL where you're predicting x.
So you do this every time it asks.
If it asks for the y, exactly. So the regression of line y on x should not be used. You need to switch the two in the x direction. Now, if I have the mean of the x's and the mean of the y's, I'm going to show you the picture and show you where that falls on my line of best fit. Right here.
That looks like a pomegranate.
It does.
Yeah. I think so.
This is also 19, 438. So here's my original LSRL. My mean will always be in the very center of that line, and my mean of x and y will always be on the regression line. This will show up on multiple choice, I promise you. So x bar, y bar will always fall on the LSRL. Probably hard to read. Write that down. If you're not writing it down, you're wrong. X bar, y bar, that ordered pair will always fall on your LSRL. It's going to be the center point.
It's on the last page. Right there.
Okay, so here we have a scatter plot. We're going to look at what happens when you add or subtract values to that, like what that does to your correlation. Suppose we add 5, 8 to our data set. I'm not going to make you do this. But we put a point out here. What happened to my correlation? It goes down. So it goes from 0.916 to 0.667 because I put a point out here. We call this point an outlier. An outlier is the one with the largest residual from the least squares regression line. So obviously that makes sense. If it's not close to the line, it's going to weaken your correlation.
How do you define outlier?
Outlier is going to be the single point with the largest residual. You only have one outlier in the data set.
If there are 2 points with equal residuals,
Then
you
they'd
say
both
there's
be.
no outliers? Oh.
You'd say both. So putting one that's far away is going to weaken your data. If I put 12, 12, what happens to my correlation? It actually went up. So I'm putting a point that's on my LSRL, but now what's it doing to my range of data without extrapolating? It's increasing it. So now before I only had from 4 to 8, now I have from 4 to 12 that keeps that consistent slope. So if you put a point that's further out but on your LSRL, that's going to strengthen. Going to strengthen the correlation. Now if I put one that's completely that changes the direction, if it's so drastic, it actually can make your correlation negative, or it can switch the sign. So here was the point. It's at 12, 0. It just wrecked everything. Yes. It weakened, and it made it negative. So all of that to say that they are both affected by extreme values, the LSRL and the correlation coefficient. So they are both not resistant. Okay, I want everyone to turn, I think you have this page in your packet, or not your packet, sorry, in your notebook. It's on, let's see, page. So turn to page 100.
Oh my gosh, we're revisiting the study.
We're back to the pomegranates.
No. No, just do people have
So this is something that we call computer output. When you have bivariate data, it's going to be presented in two ways. It's either going to give you the two original lists where you're putting it in the calculator, or it's going to be computer generated data that they give to you in this form called computer output. They'll either give you one or the other. I'm showing you both because we've already done the two lists. So now we can compare to how the two lists compare to the computer output. This right here is called computer output. We don't need like 95% of the numbers for this unit, and we'll learn most of them later on, but y'all aren't mature enough for those yet. So we're going to cross a lot of things out. You're not old enough. So we're going to cross a lot of things out. We are only going to keep the first column, so you're going to cross all of this stuff out for right now. We just don't need it. So immediately when you see this, I want you to cross that out. I also want you to cross out the r squared adjusted.
Literally 50.
So this number, this negative 269, as we remember from our first time we did the LSRL, that's our y-intercept. It is always next to the word constant, because sometimes they like to switch it up on you. So it's not always your first number, it could be the second one. Sometimes they switch them around. So y-intercept goes with constant, and then our slope goes with our x variable, which is days in this case. This next number right here is our r squared, which is called the coefficient of determination. If we want to get r from that, we're going to have to square root. So you must square root to get r, so it's going to take a little math. Then, when you square root any number, it's a positive number. It's going to give you a positive answer. But my r's are not always positive. So you must remember to match the sign of your slope. So put remember to match slope sign.
So you can have a negative R?
Uh-huh. If you have a negative slope, you have a negative r. Then lastly, this is our what we call standard deviation of errors or of residuals. Does anyone remember what the script is for standard deviation? Remember from I think it was one of the quizzes where I said interpret the standard deviation? The average distance from the mean. In this unit, it's the average distance from your LSRL.
Is that on the Y?
Mm-hmm. So it's like the average residual, essentially, is this point. So you might want to write that down, because I might ask it. The average distance, or the typical deviation from your least squares regression line, your LSRL. The last thing is the question that you saw at the end of the homework, where it asked you whether it was a good fit for the least squares regression line or not. Like, was this data appropriate? That's a big question that they will ask you, because you could type in any two sets of data and it would give you a line of best fit. That doesn't mean that's what you should have done, because it may not be linear. So the important questions is the line appropriate? Are there any unusual aspects that we need to consider to make predictions? Like, are there any outliers? Is the data curved? Something? And if we do decide to use the LSRL, how accurate will our predictions be? One way to decide this is by making a residual plot. So what I want you to do is I want you to put this data into L1 and L2. This example is a little more interesting. So let me give you some context before you type it in.
Mouse cancer was good.
So researchers were interested in how the distance of a deer mouse will travel for food. So how far these mice are going to travel for food? Or are they just lazy? So you could put this in your own life. Like, how far would you travel for food?
Apparently,
For food?
25.
Yes.
Depends. What food?
How far is it to the vending machine?
So L1 and L2.
So,
So you should get a least squares regression line that matches mine. I used the computer output. These two numbers right here. Negative 7.69 is my y-intercept. 3.234 is my slope. When you're doing this and I ask you to find the LSRL, I want three things. I want the equation. Then I want you to define your variables y, hat, and x. If you didn't do so on the little quiz, then that'll be partial.
wait,
Oh,
what?
What if on the graph you
Context.
said on the Y, this is Bill, this one, it doesn't matter.
Wait,
Didn't
where
you say
were
that
we
if there was
supposed
time at the end of
to
class, you'd let us finish
define
it?
our variables?
I don't think we'll have time.
Unless
I
we
think we
do.
have
You just put x is bills, y is
What if we put that on the graph?
maybe. We'll see.
That's what I did. It must be points.
We haven't learned it yet.
So you need to define your variables. Define. I need to know what x and y are. I just got this from computer output. So here I have this nice little linear regression equation, but I don't know if it's good or not. So I'm going to decide, how do I tell that? Looking at this, I'm going to go back. Before we do anything, if I were to just so happen to interpret the slope for this, what could that say? Just in words. We don't have to write it down.
For every increase in distance that deer mouse would
Yeah, I don't know what they're measuring it in.
meters.
Meters. So for every increase in 1 meter of distance to the nearest pile of woody debris, there is an increase of 3.234 meters that the deer mouse would travel for food.
So you do X, then Y.
Mm-hmm. The y-intercept would be when the mouse is at the pile of woody debris, so when there's 0 meters between that, then the mouse will travel negative 7.69 meters. Does that make sense? No. So the y-intercept would not make sense in this context. Here is the scatter plot, and I have drawn in the least squares regression line. The vertical deviation we call is the residual. So any points above the regression line is going to be positive, and any below is going to be a negative. The way that you calculate residual is, so the formula is equal to observed or actual minus predicted. And I remember that by AP. You're taking AP stats. Residual is actual minus predicted. And it's those y values, not the x values. How far away your data point is from the line. The formal definition is y minus y hat, but it's the same thing as actual minus predicted. So a way that you could, so if you go into your L3, so go ahead and go into L3, and you highlight L3, and we're going to put in our least squares regression line. So equals, what was the slope? 3 point, does anyone have it written down?
3.23.
3.2334 times L1 minus 7.69. Is that right?
Yeah.
Or you could do negative 7.69 plus 3.234 L1. You should get all of your predicted values. So that's going to go into my list 3. Then you can go into your L4 and calculate the residual. That would be L3 minus L1. So these are the values that you get. I think you can. I just...
Oh, shoot.
Oh, is that the residuals?
do some that are positive and some that are negative. They should all add up
So you do
to
the next one.
No, that's not what I
You do
L3 minus
This isn't.
L1.
L3 minus L1.
Yeah, L2, sorry. L3 minus L2.
So, like, say
Now.
I got the wrong signs. What does that even mean?
The wrong signs. Did you do L2 minus L3?
What did you do?
I did indeed.
That's probably why, so it should be opposite.
L2
L3.
minus L3.
L2 minus L3. I think I've been saying it wrong. You're doing
Yeah, you said
observed
L3
minus predicted. So you're taking this list minus this
So
list.
this would be 2
L-
minus
2 minus L3.
3. Okay.
I might have just said it wrong the whole time. I'm very sorry.
I see.
I think I'm starting to
Oh, see,
understand.
now it looks right.
There we go. So these
Error,
are
data type.
these are all of my residuals right here. They should add up to 0. Now you can, normally a question will just ask you about one individual point, so you don't need to do this for all of them. It'll probably just say, what's the residual when the distance from debris is 8.16? So you would plug it into the equation to get this and then subtract. So normally they'll just ask about one x value and ask, do you know how to solve? You won't have to go through that whole process.
Can you put in the y hat equals -7 that one?
So from there, once you have the data in, just the original data, and you have calculated the least squares regression line, you're going to create a residual plot. So we're going to make a scatter plot of the residuals, where my L1 is going to be my x-axis, my y-axis is going to be all of the residuals. We want to see if they have a linear relationship. What we're looking for is no pattern. So when we graph the residual plot, we're looking for scattered points. We want them to look like stars in the sky. So we want them to be scattered. If there is no pattern, then the linear model is appropriate. And this script is on page 99 too. So you can put page 99 script. I'm about to show you.
So second y equals.
So here's 2 examples of what is good and what is bad. A lot of times, because we are very over analytical people, I think we can all agree to that. A lot of times students will try to find a pattern when there is not one. So sometimes students will say, well, see with this I can connect the dots and there's a pattern. So I'm going to say it has a pattern. And my answer to that is don't overthink it. Don't overthink it. It's probably not a pattern. Okay? Unless it looks something very obvious, it has to be very obvious for it to be a pattern. Otherwise, it doesn't have one. Don't try to stretch the imagination and make a pattern if there's not one. So the one on the left is good. We would say since the residual plot shows no pattern, the linear model is appropriate. The one on the right, we would say since the residual does display a pattern, the linear model is not appropriate. That means we shouldn't have used the LSRL. We need to do something else. So all the work we did is for no good reason. So we're going to make a residual plot out of the data that we just did. So I want you to go to, I'm not going to get the calculator out. I think you can handle this. So I want you to go to second y equals. I want you to turn the plot on. Then you're going to use the scatter plot, so the first one, where your x list is going to be L1, but you're going to change your y list to resid. And I need to get my calculator because I don't remember the exact button of what it is. So for the Y list, you're going to hit, so go to second, stat, and then it should say resid.
How does it know that?
Second, stat 7. What?
How does it know that L4 is position?
It doesn't. It actually has the residuals stored, and it's not even using L4. It's using the residuals that it stored from when you calculated your LSRL. So every time, you could, but that's just a lot of work. So every time you calculate your LSRL, the stat wizards will hide your residuals inside the calculator. And then you can use them to plot. So the only thing, my only caveat to that is that if you don't, like if you type in your data and you immediately want a residual plot, it's not going to be there. So like my calculator, if you can see it, it doesn't have residuals because I've never calculated a LSRL on this. This is brand new. So it doesn't show up.
You want me to zoom 9?
So then hit zoom 9 and your graph should look like this.
Sharpen up the back.
Does it look like this? When you're drawing it, all I want you to include is residuals. You're going to make a little T. You need to label your X and then draw your data points. You don't need numbers. You don't need them. You can cross out the numbers. But I do want the data points. I want you to label your axes.
This is what you do when you do a resistant or residual plot.
Yes.
So this means that it's